matter, but each of them have an index value in any case. And we get this index, and we want to set the pawn actor array and the pawn array. We have to update them with the faction of the pawn and the pawn itself. So we set the array element at that index for those arrays to the faction of the pawn and to the pawn itself. Yep. And finally we add the mesh components. The mesh components are these meshes here. All of these, we want to add them so that the toolkit understands that we want to use all of these meshes later on. And first we check if we're using decals or not. So if we are using decals, we want to add these decals instead of these meshes. So if this is true, then we first decide the size of the decals that we are using some pretty basic math here, and then we add each of the marker decals. So all of these markers that shows the current pawn or the hover marker, stuff like that, we set their scale as well. We're scaling them relative to the default tile, so we're getting the size of the decal component that we're using, and we're getting the tile bounds, and we're scaling them relative to these. So the default value for the tiles are set to 200, though I've done some small adjustments here to make them slightly smaller in this case. But yeah, it checks the tile bounds and scales them. And if we are not using decals, then we add a lot of meshes instead. So we add an instant static mesh components for many of these. For most of them actually. We have static meshes for some, but a lot of the meshes in this toolkit are used for multiple meshes that are shown, a lot of them at a screen at a time, so it's often better to use instant static meshes. So I do that for the tiles in sight range. So we add an instant static mesh component, we set this value to contain that instant static mesh component, and we set the static mesh of the tile in sight range material component to the tile in sight range mesh, which is the one we've set up in the public variable, and then we scale it relative to the default tile. Now it's saving. Should disable that for making tutorials. Well, it does the same thing for all the other tiles as well, for the tiles in move range, for the hover marker, for the current pawn marker, and so on. After it's done with that, we set our spline component. So the spline component is the spline that shows movement trajectories between pawns and their targets. So we add a spline component for the one that shows movement and one for the ones that shows range, for the ranged attack trajectories. And we set a variable called spline mesh length that's used in other functions later, depending on the tile bounds of our default tile. And finally, we add an instant static mesh component for if we choose to not display paths as a spline but as instant static meshes instead, then we set that instant static mesh here and set it to be the path mesh. Let's see. So it's pretty slow today. There. Here it's showing as a spline. And let's see. Here it is as a mesh. So that's where we set that up. Right. Let's see. So there I think we've gone through all the stuff in the event graph. But like I've mentioned before, there's loads of more stuff in the grid manager underneath or inside these different functions and macros, but these are called from other blueprints. So I think I will describe them when they are called in their particular blueprints, since then it will make more sense for the context in which it is used. But so we will be returning to the grid manager in a sense, but this is what I will talk about the grid manager for now. So let's move on to the next blueprint. So now it's time to look at the game mode. So the game mode, let's see. So the game mode sets up a lot of stuff at the start of the game, and in later turns and also the first turn it chooses what pawn is to be the current pawn. And then when it has chosen a pawn, it decides whether or not to activate the player controller or the AI controller, depending on the faction of the current pawn. So that's basically what it does, but let's describe it in more detail. So at the start of the game, first we spawn the AI controller, and we set a reference for it, and then we find our grid manager. There should only be one grid manager in the game at a time, so it gets all actors and gets number 0, and it sets the grid manager reference to that value. So that will be set to whatever grid manager is placed in the viewport. Then it creates the HUD and adds the HUD to the viewport, and then we sort all the pawns we have in the game in initiative order. So this is a really simple sort algorithm, really. It puts all the player pawns first in initiative and then all the enemy pawns afterwards, and the order in which it does it is actually the order in which they were placed in the level. So it gets all the unit actors, set a unit parent here, and for each of them it then checks to see, is its faction a player, then we add it to initiative order. If it's enemy, we don't. And then when we're done, we do the same thing, only we look for enemies instead. So then all the enemies are added last. So this is a pretty simple one. There is another one which is unused, as you can see, that sorts pawns in the initiative order depending on an initiative value. So this is here, so you can add it if you want. Here I'm using the damage value to sort them, but you would replace this with a custom initiative value you would add to unit parent. But this works too, and you can just replace this one if you want to use that instead. There are many ways to sort pawns in initiative order, of course. And then we set the current pawn to be the first one in the initiative order. Then we wait for a little bit, and there are a few reasons for this. We have other blueprints as well that does stuff on event begin play. So we want to delay so that we're sure that all that has been updated before we move on. Then we spawn the grid camera in the level. Let's see, and we also set the camera to be the same transform, the same location as the current pawn. So we start by hovering directly over whatever is the current pawn. And we set up a reference. Okay. Then we find the faction of the pawn, which is the current pawn. We get the faction here, and we check. So if it's a player, we set player turn to true. If it's not, we set player turn to false. And if it's not the player turn, we disable input. We enable if it is a player. Yeah, and this is a interface call that calls to the HUD blueprint that just changes the little white text in the top left corner to either player turn or enemy turn. Yeah, I'll look into the HUD later. And it sets the grid camera ref to is panning is set to false. This means that it is not panning, the player is not currently panning the camera, and that means if follow cam is set to true, it will follow the current pawn. Okay, and then it checks the current pawn. Has the pawn acted this turn yet? That's the value within current pawn. And if it has already, that means that we have gone through the entire initiative array and are at the start again. So then, in that case, a new turn has started, and we make sure that, let's see, that has acted this turn value is set to false, and we add 1 to the turn counter. Actually, this kind of doesn't make that much sense when I look at it. I think this will add to the turn counter for every pawn on the next turn. Well, I'm not using the turn counter for anything yet, but I'll have to fix this before the next update, if I'm right. But in any case, the basics will be the same. And then afterwards, when looking at now it looks at, is it the player turn? Which means, I mean, was the pawn that is the current pawn now player or not? If it is the player turn, then we set the visibility of the hover marker, which is what is hovering under your mouse when you're hovering over a tile. We set the visibility to true because we want to see that on player turns. On AI turns we don't want to see that, so we set it to invisible. And then we get the player controller and we activate unit, which is a custom event inside that controller. If it's an AI, we instead wait for a second, just so that, well, if this is just looks better if the AI waits a little bit before they start running. So you can remove that and that will work just as well. And then we activate the AI unit in that case. And that's basically it. Though we have one last one here. This is called when a unit ends its turn. So this is called from, I believe, the player controller, or maybe, yeah, I think so, or the AI controller. If we choose next pawn, then we also delay for a little bit, perhaps set by whatever calls this event. And then we reset the current move of the current pawn to its max move. So the next turn it will still have its maximum move value, in case we are using movement where you can split up your movement. And then we set has acted this turn to true. And then we set the current pawn to be last in initiative order. Remember, this is when a unit ends its turn. So that means it is currently at the top of the initiative order. But now we want to move it at the bottom, so all other pawns get to act before it gets to act again. So then we use this function, which is let the first pawn in initiative order become the last. It's a bit biblical, but descriptive. So how do we do this? Well, we get the pawn at initiative order 0, that means the current pawn. And we set it to be at the index of the initiative order, which is equal to the length of the initiative order array. This means that it's one more than the maximum indexes in the array, and so we have to increase the size of the initiative order array by 1 to add this. So that means after doing this, we have an initiative order which has the current pawn on the top and at the bottom. So therefore we also remove index 0, the first index, and that's sorted. Okay. And then we find whatever pawn is currently at initiative order 0, that will be our next pawn, and we cast it to unit parent, and we set the current pawn to be equal to this new pawn. And then we again check which faction it is and do all the stuff we were talking about earlier. So that's basically the game mode. Actually, it's a bit simpler than the last one, the grid manager, I mean. Okay, so let's move on to the next. I mean, it's natural, I guess, to look at the player controller next, where we handle all of our input and a lot of other stuff too. So, okay, here are a few different things to look at. Let's start at the beginning. So also here we set up a few things. At the event begin play, we just set up some references so we can easily reference these other actors later on. we get a reference to the grid manager, such the grid manager reference, and to game mode. So that's that. Okay, so activate unit. This is what is called from game mode that I was talking about earlier. So when we activate the player unit, what happens? First we set disable input here to false. We want to be able to have input after we activate a unit, and we set the idle value of this unit to true. This interacts with the unit's parent blueprint. And then we activate the path finding functions. Okay, this is one of the big ones. I'll have to speak about this one for a bit, I think, but you see that the pathfinding function has a lot of inputs. So firstly, it's called from the grid manager. It is within the grid manager, and it has a start index, which is let's see, which is the index that we start our pathfinding from, and it has a current move, which is the range in which we want to search for possible paths to move. And then we have continue beyond move range. This is, do we want to continue searching beyond what is the move range of the unit? And this can be used for a few different things. For AI, it's used to, if the AI doesn't find any enemy pawns within its movement range, then it continues searching until it finds one, and it moves towards that pawn. For players, you can use it to display some tiles as not reachable, but you can reach them in the next turn, as you would in Civilization, or have a different sort of color tiles for tiles that you can dash to, or you would have to add that yourself, but that would be quite simple. And then we have can you move diagonally? Is it possible to cross corners? Do we display the tiles? We usually want to do that for the player, not for the AI. And we have another one, AI stop continue if target found. We can activate this for the AI. So if we've set it to continue searching beyond the movement range, should we stop searching at the moment we've found a possible target? So this is can be useful to not have it search on for a very long time, which can be slow. So that's the inputs of pathfinding. So to show how it works, we'll try playing here, and it's perhaps easier to explain if I show a unit moving. So in this case we have the start index of the pathfinding function here, and it is out to the move range of this pawn, which is 6. And it depends of course on the terrain and on pawns that are in the way. So how does this pathfinding work? Well, it's using something called Dijkstra's algorithm to get this pathfinding, or something similar at least. So what we're doing basically is that first we start with this tile, and then we look at all of its neighbors. So we look at all of these tiles here, and then if there is nothing on them, if there's not another pawn on it, if it is walkable, if the edges between this tile and the edge on this tile are both not 0, and they are lower than the remaining movement of our current pawn, then we add it to an array, to an open list we call it. So this is one tile that we are going to search further. So we look at all these tiles. So it starts here. We can add this. The edge here is 1. Then we can add it. We do the same with all of these, and then it finds the edge here is 0, even though the edge here is 1. So we don't add this. And then when we've added all of these, it looks at one of these tiles, and then it looks on all of those that are around. Can we move to this? Yes, we can. This? Yes, we can. This? We can. Yes, we can. This? Yes, we can. But it has already been added to the open list, so we don't add this. And then we look at this tile, do the same thing. We do that over and over and over again until we have reached our movement limit. And then we display all of these tiles. Also, there's one more thing. Every time we add a tile, we also add a reference to its parent. So this tile knows that this is its parent, because this is the tile that searched for that tile first. And this will be the parent of this tile, for instance. So then when we have an endpoint like this that player is hovering over, we look at this tile and we see, what is the parent of this tile? Oh, it's this. What's the parent of this? This, and that way we can generate a path by looking at the parents of each tile. So that's basically how it works. And now we'll look at the blueprint so we can see that in more detail. Okay. So let's see. So we're going into the pathfinding function, which is contained within the grid manager, as you can see here. It's a pretty big function and there's a lot more hidden inside, but we'll take it one step at a time. So we start here with all our inputs. We set the start index to current index, move range to move range. Then we clear all in-range mesh markers. So if we had any of these blue markers there beforehand, we want to make sure that there are no meshes here. So we clear them all, and we clear them. If we're using decals, we clear the decals by doing a loop through our decal array and destroying all of them. Or if we're not using decals, we're clearing all the instances of these tiles in sight and tiles in move range instance static meshes. And then we set max move. This is how far we will want to search in total, which is equal to move range plus continue beyond move range if this is higher than 0. Then we clear the reachable pawns array. This is an array that keeps track of all the pawns it finds when it searches around our current pawn. So we clear that so we don't get any of the old pawns that were added in previous pathfinding searches. And then we clear the can move to array, which holds all the possible tiles we can move to. We don't want to keep any of those from earlier searches. And then we resize the can move to array to be the size of the grid again, because when you clear it, it's set to 0. Then if max move is higher than 0, if it isn't higher than 0, then we might as well not do the pathfinding, so we just stop. If it is higher than 0, then we continue. Then we add the index of the current pawn to the open list. So that means this is the first index that we're going to search for neighbors. And it has a cost of 0, and its parent is itself. Then we do a for loop. So we loop and we check movement and we search for tiles until we have reached our max move. So max move is the last index here. Okay, so we start with our first index. So that means we're checking the tiles that we can move to at movement of 1. And then we search and add adjacent tiles. So how do we do this? Well, we look at our open list, which in the beginning, remember, is only the only thing on the open list is the index of the current pawn. So we look at that, and then we want to look at all its neighbors. So we do a loop and we check, is max move lower? Is the array element cost? So that means the cost to move to whatever tile we are searching from now. So yeah, the cost of this tile would be 0. The cost to move to this tile is 1. The cost to move to this tile is 2, and so on. So if we're looking at this, this has a movement cost of 2. So we look at the tiles surrounding it. But before we do that, we want to know, is the cost to move here lower than the maximum move of this guy? If it isn't lower, if it is as high as the maximum move, it's no point searching because we can't move to any further tiles anyway. So we check that first. If it is true, then we check if the array element cost, same thing, is equal to the current search step. Now the current search step, it will start at 1 because this is the first. We search for movement number 1, and then we search for movement number 2, and so on. So if it is higher than current search step, that means that it probably has a higher cost, like one of these slow tiles here. So we wait, we don't search for that yet. We wait until the current search step is equal to the cost of moving to this, or moving from, actually in this case, that tile. Yeah. So if we don't want to look at this yet because the cost of moving from it is too high, then we add it to the delayed search list to be searched later. If it is true, we want to search it now. So we check if it's a hex grid or not, and we have some different kinds of searches if it's a hex grid or not a hex grid. So we'll look at square grids first because they're easier. So here we search north, east, south and west first in the square grid. So here we are. So this is east, west, south, north, as I've explained before how these work. So this is like, you know, the index to the right, because it's +1, so it's one array index higher. And for this we want to search this tile and add it if we should add it. So the direction we are searching, so this is the index we are searching, which is equal to the index of the parent plus +1, so the one to the right. The index of the parent is simply that, the index of the tile we are searching from. Parent cost is the cost to move to the parent, and then we look at the edge of the child. That means the new tile we are searching at. What is the value of its edge? So if it's 0, we don't want to move to it, for instance, because that indicates a wall. And the edge of the parent, the tile we're moving from. If the edge towards the tile we're moving to is 0, we don't want to move there either. So search and add tile. Firstly, we check if the tile we are searching now is already in the can move to array. That means it has already been searched. In that case, we don't want to search it again, or we'll have an infinite loop. So we stop there. If it's true, if it's not on the list, then we check, is the edge of the child, is it greater than 0? And if it is, then we may want to add it. And then we check, is the edge of the parent greater than 0? If it is, then we might want to add it. And then we check the pawn array of the index we are searching now. So is there a pawn on the index? So if it's not, if it's empty, we may want to add it. If there's a player on it, then we add it to the reachable pawns array. This is used by the AI to find a target. If there's an enemy on it, let's see now, we're saving again. Yeah, if there's an enemy on it, we don't do that. So if it's empty, then we check, is the cost of the parent, so the cost to move to the parent we are searching from, plus the edge cost, the edge cost of the child we're moving to. So we add those together, and is that lower or equal to the maximum move? If it is, then that means we can move to this tile, and we add it to the open list, so it can be searched later. That we search for new parents, new children, I mean, for that tile. And then in that case, and also in the case if there's an enemy or a player on it, we add it to the can move to array. So it means that we can move to this tile, we can move to these pawns too, but we can't move from those tiles that there's an enemy or player on. So we don't want to search with that tile as a parent. Though you can modify this if you want to be able to move through friendly pawns, for instance, though that's not how it's set up by default. And yeah, that's basically how the pathfinding works, though there's a bit more to it still. So then we check, do we want to search diagonals as well, which is depending on the diagonal movement boolean here. So if it's true, then we search diagonals just like we would search northeast, south and west basically, because there's no difference. If we cannot cross corners, then we have a slightly different and a bit more complicated version, because this one, in addition to checking the tile we are moving from and the tile we're moving to, if we're moving diagonally, we also have to check the edges of the indexes that are between the two tiles we are moving between. So we also get some of these other tiles, and we also check these. So we check 4 different tiles to see if their edges are higher than 0. But other than that, it's basically the same. So for hexagonal tiles, you never have to worry about corner crossing because there's no corners with hex grids. But you do have to worry about whether you're on an even or an odd row, because that's a bit different from each other. I can explain quickly why, actually. So, thing is, if I should make a small grid for this so it's simpler, or I can just make this grid smaller temporarily, or a bit larger. So, there. So this is one of the even grids. So if we are here on number, so this is 0, 1, 2, and we want to search all of these. So we want to search the one that's +1, the one that's -1, and we want to search the one that's +1, 2, 3, 4, right? And so the one that's +4 and the one that's +5. But when we're searching our odd rows, like this row here, we want to search +1, -1, just like before, but we want to search 1, 2, 3, 4, 5 and 6, right? Instead of 4 and 5, like it was before. So we have to make these small adjustments for what row we are on. So we check which row we are on by doing some simple math, and then we have 2 different, slightly different functions, which are basically the same as the last one we went to, but we're checking slightly different indexes each time. So that's the basics of how that works. And when we have searched and add tiles, we clear the open list. We don't want to search the same tiles again. We add one to the current search step. Maybe we want to display the tiles. That's depending on this boolean, which is connected to the start here. So if we want to display them, then we check, is the move range lower or equal to the current search step? So are we searching now beyond the move range of the current pawn? Then we might want to display a different kind of tile. So I made a couple of different functions here. So if we are still inside the movement range of the pawn, then we want to add a tile in move range marker, so either a decal or a static mesh. So if we're using static meshes, then we check in the open list children. So this was, like you see before, we added all the new potential tiles to move to the open list children in the earlier function, and for each of them we want to add an instance of the tile in move range material component at the rotation of the rotator array, and at the location of the vector field array on the index of that particular tile. And we have it hovering above the grid slightly, so it's not overlapping completely the grid by a very small amount, which can be set customly, or can be customized in the grid manager. For decals, it's pretty similar. We get the same indexes from the open list children and let them through the vector field array to get the location, and we spawn a decal. Now it's difficult to delete all the decals later, or to find a lot of decals and delete them, so we make sure to add every decal we spawn to an array so we can easily find all of them, and so we can delete all of them at once later when we want to do that, like you saw in the clear tile in range marker meshes function we looked at earlier. So that's that. And this one at the edge and beyond is similar, though with different meshes. Okay, then we want to stop pathfinding if there are no more tiles to search. So if the open list children is equal to 0, we don't want to continue to search even though we still have more movement to search for. Could happen, for instance, if you're blocked in by walls. We don't want to continue searching. So if there's no possible new tiles to search, we stop searching. But if there are any someone to search, we have to check, is the current search step lower than the move range of the current pawn? And if it is, then of course we want to continue searching. If it is not, then we check, is it lower than the maximum move we want to search, if we want to search beyond the movement range of the current pawn. So if it's not, we stop. So if it is, then we want to check, should pathfinding end if a unit has been found? So it should not stop, then we just continue until we've reached our max move. And should we continue to search if no targets have been found? This one. So yeah, that's what I was. Yeah, so that's, these are connected in that. So it's checking the reachable pawns array. So if it has found a pawn, so it's not equal to 0, then it stops. If it has not, then it continues searching. So if it continues searching, it appends the open list children to the open list. That means all the potential tiles, we now make them actual tiles we want to keep on searching. And we add the delayed search list, the one we saved that we could not move to yet. We also add that to the open list so we can search them again. Maybe we can move to them this time. And then we clear the delayed list and declare the open list children. And here's some junk I've kept, it seems. Okay, so if we end the pathfinding, then we clear the open list children in this case as well. We set the current search step to 0, so next time we run this, it starts at 0. We clear the delayed search list in this case as well, and we add the index, the current index. That means the index we started searching from. We add that to the array of tiles that can be moved to as well. And that's the pathfinding in quickly described. I hope it makes sense. Just look into it more yourself, and hopefully it will make even more sense. And if you have trouble understanding it or want to modify it, just send me a message. This is kind of, the heart of the toolkit in many ways. But we were talking about the player controller, weren't we? So we call that when we activate a unit, but we also call the find tiles in range. So we simultaneously try to find all places we can move to and all tiles we can attack, basically. So this is also one of the really big functions, and also within the grid manager, contained within the grid manager. So we have a few inputs here. Start index, just like in pathfinding, this is the index we search from. Range, this is how far we want to search. Check visibility, this is do we want to check if there's anything blocking in between. So I should probably just make a new stage to make this easier. Let's see. And I like to have it zeroed out, even though I've added a lot of stuff to make sure that's not a problem. I still prefer it. And there, and some tiles. There. And let's make sure this guy has some... Oh yeah, you can't, of course, see his visibility, or can you? Let's see. Yeah. So now this is visibility. So in this case, we're checking visibility to the tiles. So these tiles are obviously in the range from his range of 6, but you can't see them because there's a tile in between. So this is what we're checking. here. Yeah, and do we want to only find pawns? That means, do we only check tiles for visibility where there are pawns on them? So let's see.